Hey, welcome back, Fast Monty's Garage. Today we have to talk about something really important. Heat soak. You've probably seen it happen to a friend, maybe even happen to you, not realizing what it is. It's very important we talk about it. So, what is heat soak? Heat soak is when a component on your engine absorbs heat from the motor when it's been sitting and causes it not to work. Sometimes it happens to your carburetor and your fuel gets too hot. I cover that in my carburetor install. But today we're talking about a starter. And let me tell you a story. So last episode, if you guys missed that, we diagnosed a exhaust leak. We fixed the exhaust leak, and I went on a test drive. On that test drive, I actually ran an errand. I went to the UPS store, dropped off a box. It took a whopping 5 minutes. Walked back out to the car, and the car wouldn't start. Just click, click, or maybe a partial turn of the starter. Man, that's embarrassing, right? Because people are checking out your car. Thank God I wasn't at a car show. Could you imagine how embarrassing that would be? Oh my God. Anyway, this has happened to me before, and I pawned it off because we had far greater issues. We had to rebuild the motor, right? So how do you know if you have a heat soak problem? Number one sign is your car starts fine when it's cold. You run your car, it heats up, you park somewhere, and now that you're parked, there's no air flow cooling off your starter. Your starter, if it's one of these original AC Delco type, is absorbing the heat, especially if you have headers. If you have headers, it's absorbing heat from the headers. It's absorbing the hot oil heat from the oil pan and just absorbing, soaking it in, right? Now the armature wires on that motor are slightly expanding, and they're also creating a ton more resistance. So unless you have a monster battery, you're not going to be able to turn that starter motor. I have an Optima yellow top, which is a decent battery. Had a hard time turning it. So when I got home from that trip, I filmed it. And I'll get to that in a second. So today, we're going to diagnose that problem. I also left a link below, those of you guys want to read it, from Hot Rod Magazine that discusses the same issue. And we're going to do the same fix. We're going to put an IMI mini torque starter in. And that will fix the problem for several reasons, and we'll get into that. But before we get there, check out this little clip from the last episode. I'll pull this starter, which is super simple. Make sure your battery's disconnected, and I'll meet you at the workbench. All right, guys, this is what heat soak sounds like. So the car's been sitting for about 5 minutes from a trip. So the engine's hot. It's heating up the starter. So I'll turn the key. You hear that? That actually got a turn out of it. We actually got maybe a half a rotation out of the engine, and it stopped. It couldn't move the starter anymore. Typically, it's just a click. So the time I did it before was a click. Brought the camera out to record it. So here's the third track. You guys hear that? So it just tried to turn, click, wouldn't go. I really doubt it's the battery. I have an Optimum yellow top and an Optima yellow top, and that's why I suspect we have heat soak. So, back to the workbench. Okay guys, here's the AC Delco type starter. You have a solenoid and the starter motor. And you can see how thick this metal is. It's crazy. So what happens is when you turn your key, this solenoid kicks a lever, and the lever actually forces this pinion gear over into your flywheel, or the gear ring, right? So then it's just temporary and it pops right back. I mentioned there's a couple solutions, actually 3 that I know of. One, the most economical solution is to actually get a shield, an aluminum shield for the solenoid. That shield is sold by OPGI. I'll put a link below. The second thing you can do is wrap this in DEI wrap, same company that makes the header wrap that we did on a previous video. They make like a blanket. It actually can cover the whole starter, gives it some more protection. I'll put a link for that below too. But what we're doing today, as I mentioned, is we're going to this. Look at the size difference. This weighs about 25 pounds. This weighs 10 pounds. Awesome, right? So you can tell it's not inline. This has an inline motor. This is offset. So here's the motor, here's the driveline angle, and this is the actuator pushes the pinion out, and there's a gear reduction that increases your torque. So when you order one of these, you can actually have 3 or 4 different options for torque settings. So this is the 1.4 kilowatt version. Again, I'll leave a link below. So this is really neat. It also comes with a pigtail for our starter, so we have to splice that in. This is obviously where battery cable goes. It comes with new bolts, socket head cap screws. It comes with some bushings, because I'm going to show you guys how we have to set the distance. These actually slip in here if we have to change this distance. These go in between the block if we need to shim that way, and I'll go through that. So that being said, first step is we have to remove this block. There are 2 Allen socket head cap screws in there, and then mount this to the engine. So I'm going to go ahead and do that, and I'll meet you guys over at the engine. Hey guys, here we go. I have the mounting block situated. If you're running an inspection cover, you're going to have to mark it, because we're going to have to cut this. It's not going to fit with that in there. So I marked it here. I'll cut it later. So it's hard. You can't mess this up. The countersunk holes in the block go down, and there's a pilot diameter for the motor. Now the reason we mock it up like this is we want to put the motor in and then adjust it to where we have the same distance from the headers as we have from the oil pan, and that will give us plenty of airflow to make sure the new motor cools faster. So it's pretty easy. We just put it in, and then we'll take our Sharpie and then mark on here and on the mating side on the block for our clocking. Hopefully you can see from this angle. You can see where the holes are and where they line up. So our options are here. That gives it, there's more space here, which I'm actually okay with because this is hotter. Or here. I think I'm going to go here, and that's the original mounting location because I already marked it on the block. Alright guys, I'm still thinking about it. Here's the inspection plate. I already marked it with this installed in the block. So I'm going to continue my line here. So I'm going to go ahead and take my bandsaw and just cut on the outer edge of that line the whole way. So now we can get our inspection plate back. Set that aside. So the next step is we're going to remount our block. So I previously marked this because I was curious where the original mounting holes were. So I'm going to go ahead and mount this back on with our screws, and we're going to put it back in the block. Now when it's in the block, we need to check for the distance here. So we're going to take a screwdriver and try and pry this out as if it's working to make sure we can engage our flywheel. And then we're going to check the distance from here to the edge of the flywheel. The edge of the flywheel is basically right here. We want about I think it's 100 thousandths. I'll double check the instructions. And that's what this shim is for. So we can put it in here and make that distance better. So meet you back at the block. Alright guys, I don't know if you can see back in here is our pinion gear. And then this is the surface of our ring gear. And you want to measure this distance between the edge of the pinion and this face of the ring gear. I clearly have plenty. This is my feeler gauge. It's a ruler. This is actually 80 thousandths. You're supposed to have somewhere between 40 and 100. I clearly have more than 100, so I need to contact the factory to find out if that's going to be a problem. It looks like 180-ish if this is 80. So I'll contact them about that, but let's go to the next step. So once you figure that out, so let's say you have less than 40, like I can't stick this in there, or I find something that is really slim and I measured the thickness. That's when you put that shim in between the block and the starter and then redo this test. So we're going to move forward as if we're good and go to the next step, which is measuring lash, and I have to think about that one. Okay guys, the little bolts that go on the front are supposed to be tightened to 95 foot-pounds. Frankly, I don't see that happening. I think I got to 40 and I can tell they're starting to strip, so I stopped there. The other thing, I had this in the car and it's damn near impossible to pull this out and measure. So I did it a couple times to get it in the teeth just to see how easy it is to move in there. And I'm going to go ahead and add one shim to the back, which goes like this. So you bolt it up. You keep one bolt in. Sorry guys. Yeah, it's on. So the bolt's going this way. The bolt's going from this side. And you can keep one bolt in, you slide it in, and then put the other bolt in, tighten it up. So I'm going to do that. One shim, just to be safe. Now I'm going to I'll splice a little pigtail. I already mocked up my wiring. My wiring with the stock length fits fine. It actually comes around the bottom and up. This one I just have to loop over like that because I have kind of like a wire harness going on, and that's not a problem. Guys, I don't know if you've seen these before, but these are pretty cool. They're connectors or for splicing. There's solder in the middle and then shrink tubing throughout, and you just put it on, twist your wires together, doesn't have to be fancy. Slip it over, and then we can apply some heat. You can see the solder shrinking. And try and flip it over. And you can see the solder spreading out in there. That means you got a good connection. Pretty cool. Alright guys, I went ahead and connected my wires. In case you guys are wondering, I have a trunk mounted battery, and this is from the alternator. Okay, if you guys are running like a Ford starter solenoid, you would actually connect this pigtail to this connector, because the solenoid fires this wire. So that's how you do it. So I went ahead and wired everything before I put the starter in, mounted it. So I'm gonna go ahead and mount it, and then we'll put our modified inspection plate back in, and we're ready to test fire. Okay, here's our modified plate. Like a glove. Alright guys, here's the test of the starter. Now it's been over a week since I ran the car, and I did not put on a battery tender, so the battery's the way it is, and we'll see if it cranks the motor fine. Hopefully it does. Hopefully my wiring is right. So here we go. I have fuel pump. Let's get the carb primed. Okay, carb is primed. Couple pumps. Oh yeah! Alright guys, ultimate test. Went to the gas station, filled up, brought the car up to temperature, came back, parked the car, had lunch, I'm about to tune the carburetor a little bit, but this is a good example of heat soak. Remember last time I showed you what it sounded like, so hopefully this time it starts right up. Here we go. So it looks like we fixed heat soak. Be right back. All right, guys, that's how you fix a heat soak starter issue. You just throw it out, buy a new one, buy a mini torque, because now we're going to have the reliability to start the car when it's hot. And how embarrassing would that be if you're at a car show and you can't start your car after you've been sitting there for a couple hours? Speaking of car shows, next week I'm going to my first quarantine cruise in Southern California. Those of you guys that don't know, that cruise was started by like 25 guys who got together when quarantine first started because car shows were shut down, and they just cruised the coast. And the next time they did it, it was like 500 guys. The next time was 1,000. Next time was 2,000. It got up to 3,000 cars. Can you imagine that? How bonkers is that? So next week is another one that I'm going to be my first one. And frankly, I'm nervous, I'm excited, a little concerned, because this is the first time we're going to take the GTO on a drive longer than 10 miles. It's 100 miles each way. And I haven't tested for full leaks or any kind of other anomalies we have to think about. So it'll be interesting. I'm going to try and film as much of it as I can. And I admit I'm probably going to be a newbie at it because I haven't done it, an actual car show type vlogging experience yet. And hopefully all the camera equipment works and yada, yada, yada. So at least you can make fun of me and check out some other cars. But most importantly, I don't want to break down. So that's number one. And if you haven't subscribed, do so, because it should be chaotic and fun and everything and all in between. But again, thanks for hanging out today. And you know the drill. Building fast, driving faster. See ya.